Welcome to the potential difference Perpetual generator demo video. What we are going to show today is a method by which we can harness generator back EMF and accelerate the prime mover under load. Lenz's law states that when a magnet approaches a coil of wire, voltage is induced in that coil of wire. When current flows in the coil of wire, the coil produces a magnetic field such that the polarity of the magnetic field produced by the coil is the same as the approaching magnet. The effect is the magnetic field produced by the coil repels the approaching magnet. Now what we're going to show in this video today is the first part is we're going to show a conventional system that slows down under load. Then we're going to harness the back EMF from our generator coil and we're going to accelerate the system under load. And we do that by taking the back EMF induced magnetic field from our coil and allowing it to couple through this steel shaft here into our induction motor. Now what we have, a quick rundown of the components are, we have an induction motor, we have a brass coupling, steel shaft, steel rotor, and a generator coil. And what I'll be doing during the video is I will be replacing the air gap inside this brass coupler, which does not conduct magnetic flux, and I will be placing this steel bar into the brass coupler, and by doing so we will be able to harness the generator coil's back EMF, feed it into the induction motor, strengthen the induction motor's rotor field, and accelerate the generator under load. In the first part of the demonstration, I'm going to be showing a conventional generator. We have a generator coil and our magnetic rotor, and here we have the motor current, we have the generator output voltage here, and over here we have a tachometer coil which is reading our system speed. What I'm going to be doing when the generator is running is I'm going to short out our coil, which is now reading 175.1 ohms. I'm going to short out the coil. I'm going to induce the maximum amount of back EMF into the air gap, and the system is going to slow down. Our generator is operating. Our prime mover is rotating our magnetic field past the coiled wire, and our generator is producing 74, 75 volts right now. Our speed is 72 RPM, and I'm going to introduce back EMF into the air gap now. As we can see, the generator back EMF is causing the system to slow down. If you just want to pan over, the system is slowing down and will continue to slow down until it comes to a dead stop. At this point, the motor does not have the capacity to turn the system. The system stops as a result of generator back EMF in the air gap. So what I've done now is I've disconnected the motor from the generator drive shaft. I'm going to insert this steel bar, this ferromagnetic material, into the brass coupler. And in doing that, I'm going to give the generator back EMF a flux path into the induction motor. And as we saw in the first part, the back EMF slowed the system under load, and now the back EMF is going to be fed into the induction motor, and it's going to accelerate the system under load. So now what I've done is I've inserted our ferromagnetic material, our steel bar, in between the generator and the induction motor. And this time when I run the test, when I short out our coil, the back EMF from the generator is going to has a magnetic flux path into the induction motor, and the system is going to speed up. So I'll just do that right now. So our system is accelerating. I'm going to short out the coil now. We're producing 94 volts. Tachometer speed is increasing, 94, 95, 96. Our coil is shorted out. Our motor current is dropping 5 amps, 4.99. Our speed is continuing to increase. Pan over quickly. And let me